Quadratic function. Our objectives. At the end of this presentation, you should be able to represent a quadratic function using table of values, graph, and equation. Observe the following images. These images has a connection with our topic. Now, let's start up. What is quadratic function? A quadratic function is a second-degree polynomial y equals ax squared plus bx plus c, or f of x is equal to ax squared plus bx plus c, where a should not be equal to 0, and the vertex form of quadratic function is y equals a times the quantity x minus h squared plus k. Remember that your a, b, and c are all real numbers. Take note also that y and f of x are the same in terms of representing quadratic function. Remember, we can identify quadratic functions in terms of its representations. It can be represented using the table of values, graph, and equation. The table of values is the corresponds of x and y values, which is ready for point plotting similar to the table of values in linear functions. Remember also that the graph is the smooth curve formed after the points has been plotted and connected that opens upward or downward. Moreover, it is an equation that represents quadratic function if the highest exponent of the variable x is 2. Otherwise, it is not a quadratic function if the highest exponent is above 2, or if it is on the y variable. Take note, a quadratic function has a U-shaped graph which is called the parabola. A parabola has a line of symmetry. This means that the part of the parabola on one side of the line is reflection of the other part of its side. The middle point is what we call your vertex. Example: the following equation are quadratic functions and can be expressed in the form of y equals ax squared plus bx plus c. We have x squared minus y minus 4 equals to 0, x squared equals y minus 2x minus 1, 2x squared plus 2y minus 11x plus 6 equals to 0, x equals 2x squared minus y equals the quantity x plus 2 squared plus 3, and 8x minus x squared equals 7 minus y. Express the following equation in the form of y equals ax squared plus bx plus c. Let's have x squared minus y minus 4 equals to 0. Take note that one side of your equation should have the y variable and the other side of your equation should have the quadratic term and other terms. In this case, we need to move x squared and negative 4 to the other side of the equation so that what left in one side is the y variable and the other side will have the quadratic term and the constant term. Therefore, negative y is equal to moving x squared to the other side of your equation using the addition property of equality. X squared will become negative x squared and negative 4 will become positive 4. Since the y variable is negative, we need to make this as positive variable. Therefore, let's just multiply both sides of the equation by negative 1. Multiplying both sides of the equation by negative 1 will change all the signs of the term. Therefore, negative y will become positive y, negative x squared will become positive x squared, and positive 4 will become negative 4. Therefore, final answer is y equals x squared minus 4. Example number 2. X equals 2x squared minus y. Let's move negative y to the other side of the equation and positive x to the other side again of the equation. Therefore, moving negative y to the other side of the equation will become positive y. Just simply copy 2x squared, and moving positive x to the other side of the equation will become negative x. Therefore, final answer is y equals 2x squared minus x. Let's have example 3 and 4. Sample number 3. Y equals the quantity x plus 2 squared plus 3. In this case, remember our PEMDAS rule. Therefore, we'll be solving first the numbers inside the parentheses. As you notice, this is an example of square of binomial. Therefore, expanding this will give us a product of x plus 2 times x plus 2. You can use the FOIL method or the Parabola method in solving for this equation. Therefore, y equals x times x is x squared, x times 2 is positive 2x, 2 times x is positive 2x, and 2 times 2 is positive 4. Then just bring down positive 3. Now, let's combine similar terms. Similar terms in this case are 2x plus 2x and 4 plus 3. Therefore, y is equal to, bring down positive x squared, then add the similar terms. So 2x plus 2x is equal to 4x, and 4 plus 3 is equal to 7. Therefore, the equation now becomes y equals x squared plus 4x plus 7. Let's have example number 4. 8x minus x squared equals 7 minus y. In this case, we will be moving negative y to the other side of the equation and 8x minus x squared to the other side of your equation. Therefore, moving negative y to the other side of the equation will become positive y equals, moving negative x squared to the other side of the equation will become positive x squared. Moving positive 8x to the other side of the equation will become negative 8x, and just simply copy 7. Remember that the first term should be the quadratic term, followed by the linear term, and the last term should be the constant term. Therefore, our equation is y equals x squared minus 8x plus 7. Take note, other than equations, quadratic function can be represented by a table or a graph. So let's have the function of x, or f of x, is equal to x squared plus 1. Let's identify whether the given table of value is a quadratic function or not. So we will be using the second difference method. So remember, using this method, we need to subtract the y values from right to left. So meaning, I'll be subtracting 5 by 2, 2 by 1, 1 by 2, and 5 by 2. Subtracting the first difference, we have 5 minus 2, so we have 3. Next, 2 minus 1 is equal to 1. Next, 1 minus 2 is equal to negative 1. And the last one is 2 minus 5 is equal to negative 3. After getting the first difference, we can now get the second difference. So to get the second difference, just simply subtract from right to left the first difference. Therefore, we have 3 minus 1 is equals to 2. 1 minus negative 1 is equal to 2 also. Take note, since the operation is subtraction and followed by a negative number, therefore, this will become positive. Then, we have negative 1 minus negative 3, still positive 2. As you observe, the second difference are all equal. Therefore, the given table is a quadratic function. Second difference method. It is a relation f. It is a quadratic function if equal difference of the independent variable x produce a non-zero equal second differences in the function value of f of x or the y value. Complete the table of values and graph. So to complete the table of values, we will just simply substitute one by one the values of x on each values of y. So let's have negative 2. So if x is equal to negative 2, what is the value of y? So we will rely on your original given equation, which is y equals x squared. So let's substitute x by negative 2. So we have y equals negative 2 squared. Multiplying negative 2 by negative 2 will give us a product of positive 4. Next, if x is equal to negative 1. So let's substitute again to the original equation, which is y equals x squared. So we have y equals negative 1 squared. Multiplying negative 1 by itself will give us a product of positive 1. Next, if x is equal to 0. So let's substitute again. So we have y equals 0 squared. Multiplying 0 by itself will give us a product of 0. Next, if x is equal to positive 1. So substitute x by positive 1. So we have y equals 1 squared. Multiplying 1 by itself, the answer is positive 1. Last one, if x is equal, so we have y equals 2 squared. Multiplying 2 by itself will give us a product of positive 4. Now, since the y values are already complete, we can now plot for the graph. So just simply draw a Cartesian coordinate plane. Now remember that this is your x and this will be your y. So let's have so remember that the center is 0, 0, and this is all positive numbers. And from 0 to the left, that will be all the negative numbers. And from 0 upward, that is again a positive number. And 0 down, that will become a negative number. So we can now plot. So if x is negative 2 and positive 4, so we have negative 2 and positive 4, so the dot will be here. Negative 1 and 1, so the dot will be here. 0, 0, so we are on the center. Then 1 and 1, so we have here, and 2 and 4, so we have here. And then just simply connect the dots. So as you notice, okay, we form a parabola. Therefore, the given equation is a quadratic function. Let's have example number 2. Let's complete the table of values and graph given y equals 3x squared. So same procedure will be applied. We will be just simply substitute each value of x to the original equation, which is y equals 3x squared. So if x is negative 2, what will be the value of y? So we have y equals 3 times negative 2 squared. So we have y equals 3 times multiplying negative 2 by itself will give us a product of 4. So we have now y equals 3 multiplied by 4, we have 12. Next one, if x is negative 1. So let's substitute x by negative 1. So we have y equals 3 times negative 1 squared. So we have y equals 3 times multiplying negative 1 by itself will give us a product of positive 1. And multiplying 3 by 1 will give us a product of positive 3. Next, if x is equal to 0, so we have y equals 3 multiplied by 0 squared. So multiplying 0 by itself will give us a product of 0. Then multiplying 3 by 0 will give us a product of 0. Next, y equals 3 times positive 1 squared. Again, multiplying 1 by itself will give us a product of 1, and multiplying 3 by 1 will give us a product of 3. Next, the last is multiplying 2 or substituting 2 by x. So we have y equals 3 times 2 squared. So multiplying 2 by itself, we have y equals 3 multiplied by 4. And multiplying 3 by 4 will give us a product of positive 12. Since we already complete the table of values, we can now graph the following quadratic function. So again, the center is 0. So these are all positive numbers. And these are all positive numbers again. And negative number. Okay, so again, this is your y and this is your x-axis. So I will be skip counting by 3. So this is 3, 6, 9, 12, 15. Then let's have 1, 2, 3, 4, and 5. Negative 1, negative 2, negative 3, negative 4, negative 5. So let's have this one is negative 3, negative 6, negative 9, negative 12, negative 15. Hi, so let's plot. So we have negative 2 and 12. So negative 2 and 12. So somehow this is your dot. Negative 1 and 3. So let's have this is your dot. Then 0, 0. So again, as you notice, it is a reflection of the other side. So still this is 1 and 3. And this is positive 2 and positive 12. Now, plot that. So let's plot. So again, it forms actually a parabola. Let's have example number 3, the last example. So we have y equals 3x squared minus 5. So substitute again the values of x one by one, okay, to each values of y. So if x is equal to negative 2 and our equation is y equals 3x squared minus 5. So let's substitute x by negative 2. So we have y equals 3 times negative 2 squared minus 5. So we have y equals 3. Multiplying negative 2 by itself will give us a product of 4 minus 5. Then PEMDAS rule, multiply first before you subtract. So we have y equals 12 minus 5. So subtracting that, that will become y equals positive 7. Next, so if x is negative 1, so we have y equals 3 times negative 1 squared minus 5. So we have y equals 3 times 1 minus 5. So we have y equals 3 minus 5. So we have y equals negative 2. So this is negative 2. Okay. Next, y is equal to, so substitute x by 0. 3 multiplied by 0 squared minus 5. So we have y equals 3. Multiplying 0 by itself, so we have 0 minus 5. And then y equals, multiplying 3 by 0 will give us a product of 0. Then subtract it by 5. So we have y equals negative 5. Okay? So substitute by positive 1, the values of x. So we have y equals 3 times positive 1 squared minus 5. So we have y equals 3 times 1 minus 5. So we have y equals 3 minus 5. Y equals negative 2. So this is negative 2. So again, reflection. Okay. So let's have the last one. So we have y equals 3 times 2 squared minus 5. So we have y equals 3 times 4 minus 5. So let's have y equals 12 minus 5. So we have y equals positive 7. Okay? Now, we already completed the table of values. We can now graph. So let's graph. So again, of course, okay, much better if you will be using a uh, graphing paper or the mathematics paper. So let's graph. Okay. So again, this is your x-axis and this is your y-axis. So 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 1, 2, 3, 4, 5, 6, 7. Okay. So again, this is 1. So I will be labeling it first. This is 1, 2, 3, and 4. Negative 1, negative 2, negative 3, negative 4, 5, negative 6, negative 7. And this is negative 1, negative 2, negative 3, and negative 4. So let's plot. So negative 2 and positive 7. So we have negative 2 and positive 7. So here. Okay. Negative 1 and negative 2. So this will be your point. Then 0 and negative 5. So 0 and then negative 5. And then of course, just a reflection. And then 2 and positive 7. Okay. Then connect the dots. Okay. So as you notice, again, since it is a quadratic function, that's why the graph becomes a parabola. So that's all. Thank you for listening. And stay tuned for our another video.